In this video, I will be going over how to read key properties of various functions. So we're going to start off with this square root function, and I will start with the domain and range, and I am going to be using the interval notation, although the original set notation from grade 11 is also perfectly fine. For our domain, it's going to be everything to the left of 4, which means we will be writing that our domain is from negative infinity, and since negative infinity isn't actually a point, I'm going to use the rounded bracket, and we're going all the way to positive 4, which is included, so square bracket, because it is a closed point. For my range, my y values are going to be everything under negative 3. This means for our range, we're starting again from negative infinity and working all the way up to positive 3, and again, we're including that value. Next, we're going on to our intercepts. We don't have any x-intercepts, as we can see here, no points on the x-axis. However, we do have a y-intercept at negative 5. So we can label that as 0, negative 5. Next, we're on to our increasing and decreasing intervals. As a reminder, we always want to read our graphs from left to right. So if I follow from the left, this entire function is on the way up. There is no decreasing interval here, which means for our interval of increase, we're going to start from negative infinity and go all the way to the end of our function, which is at 4. And I'm not including 4 for this interval because 4 is a point. It is not a point of increase or decrease. It is just the end of the interval. And for the interval of decrease, I will just write none. Next, we have our positive and negative intervals. For the positive interval, we want to see if there is anything above the x-axis where all of our y values are positive. In this case, we have none. For negative intervals, we want to see anything below the x-axis where our y values are negative, which is where our entire function is. So I will make a point, positive interval, none. And for our negative interval, from negative infinity all the way to positive 4. And at 4, the y coordinate is actually negative, so I am including that value. Next, we have our end behaviors. So I'm going to start with as x approaches infinity. So as I follow this function and I'm going to positive infinity, well, the function ends at 4. There is nothing past 4. So this does not actually apply. So as x approaches infinity, y does not exist because it just stops at 4. As x approaches negative infinity, so as I follow my function towards the left and I get closer and closer to negative 10, negative 100, and so on, I'm going to negative infinity, my y values are becoming more and more negative, which means y approaches negative infinity as well. Next, for our continuity, this function is continuous. There are no holes, there are no asymptotes or breaks in this function. Symmetry, there is no symmetry here. There is no line that this function can be reflected on to get the other half. There is no point that we can rotate along to get the other half, so there is no symmetry here. Turning points, there is no change in direction, so there are no turning points. And finally, for our extrema, meaning our maximum or minimums, there is no minimum because our function continues going down forever and ever, although we do have that point at 4, negative 3 that we can say is an absolute maximum. And there we are, all the properties for this square root function. We will try another one for this function here. Same properties again, which means we're going to start with our domain and range. For the domain, x can be anything. So we're going from negative infinity to positive infinity because these arms here go forever to the right, forever to the left. So we're reaching positive and negative infinity for our x's. For our range, we do go up forever, but we do have a minimum value at these points here. Now we are going to have to estimate them a little bit. We're just under -1. So I will roughly estimate this as my lowest point, which I am including. So negative, let's say 1.1 to infinity for my range for those y values. Next we have our intercepts, and we have quite a few x-intercepts here. I have one at -4, -2, +2, and +4. So I will list all of those. -4, 0, -2, 0, +2, 0, and +4, 0. We also have a nice y-intercept that we can read right here on the y-axis, and that is at 0, 2. Next, we have our increasing and decreasing intervals. So here we do have quite a few changes in direction, so we have to be careful when we're labeling. So for an interval of increase, reading again from left to right, we start off decreasing, but once we hit this point here, we have some increase happening. Then the function decreases, and then once it hits another point, it increases for the rest to infinity. So we have two intervals of increase here, and I am going to estimate a little bit. So the point at the start, maybe here, it's a little bit to the left of -3. So I'll just say -3.1 to 0. So from here to here. And then this one, maybe I'll estimate it as 3.1, and it goes on forever, so to infinity. And that's where I am increasing. The other sections, so from -infinity all the way to that -3.1, we're decreasing from left to right. And then from 0 to 3.1, another interval of decrease. There we go. And again, reading from left to right. Next, we have our positive and negative intervals. So again, looking above the x-axis, we do have quite a few segments here. So our first segment is going to go from -infinity all the way to -4 because this chunk here is all above. Then we have from -2 to 2, this section here is in the positive, and from 4 all the way to infinity, it's above. The only section that is negative are these two sections right here. So our positive interval, we're looking at -infinity to -4, -2 to 2, and 4 to infinity. And you'll notice the points that I'm using in these intervals are the x-intercepts, because at the x-intercepts is the place where you would have a change from positive to negative. My negative interval from -4 to -2, and from 2 to 4. Next, we have our end behaviors. If we look at our arrows, whether I'm going to the right or the left, I am going to positive infinity forever in both cases, meaning as x approaches infinity, so as we go to the right, my y values go up forever, and as x approaches negative infinity, so as I look to the left, my y values also go up forever. Next, we have our continuity. There, again, no holes, no asymptotes, so this is continuous. Symmetry. This does have symmetry. It is actually line symmetry, because if I were to put a line right here along the y-axis, if I take my right side and reflect it over the y-axis, I will have my left side. So this is line symmetry. And because our line is actually the y-axis itself, this is even symmetry. Finally, turning points. We do have a few because there are a few changes in direction. We have a turning point here, here, and here. So I'm just going to label them on my graph. So we have a turning point at, again, I am estimating here, -3.1, comma, -1.1, another one here at 3.1, comma, -1.1, and then that y-intercept of 0, comma, 2. And these turning points are actually also part of our extrema because they are max and mins. The two bottom turning points at the -1.1 y value, those are actually our absolute minimums, both of them. And our top turning point, because it isn't the very highest point on this graph, it is a local max, because within this area here, it is as high as it goes. But of course, if we look at our end behaviors, we do have arrows going up forever. So there is no actual absolute maximum because the function doesn't end as we get higher and higher. So there's another example that has a little bit more going on compared to our first square root function. And we can do our final example here, which looks sinusoidal. And we're going to start with our domain and range again. Now we will see that this function does go on forever towards the right and left in the cyclic nature. So our domain is going to be all real numbers, or using our interval notation, -infinity to infinity. Our range, we do have very clear max and mins. So our maximum is 4, our minimum is -4. We are including those values, so -4 to 4. Intercepts. Now I did make a note here saying read points and intervals from -10 to 10. So we're just going to use the visual that's in front of us, because if we were to use our entire domain, there are an infinite number of intercepts and intervals of increase and decrease and positive and negative intervals, because this period does just repeat over and over again. So for our x-intercepts that we see, we have -8, 0. We have -4, 0. We have the origin. We have 4, 0. And we have 8, 0. For our y-intercept, it's the origin. So it's a common point between the x-intercept as well. Now our interval of increase. I'm reading from left to right. So my interval of increase, I'm increasing here and I'm increasing here. So in terms of my x values, we're looking from -6 to -2 to to 6. So interval of increase. And our interval of decrease is the exact opposite ones. So again, we're just using what we have in front of us. So we're going from -10 all the way to -6. We're going from -2 to 2 and 6 to 10. Now for our positive and negative intervals, we're looking at everything above and everything below the x-axis. So for our positive interval, everything between -10 and -8 here is positive. From -4 to 0, from 4 to 8, all of that is in the positive region. -10 to -8, -4 to 0, and 4 to 8. The negative interval is going to be everything in between. So -8 to -4, 0 to 4, 8 to 10. Next we have our end behaviors. Because this is a sinusoidal function, it is oscillating, meaning it is going up and down forever in both directions. So we don't really have end behaviors here because as x approaches positive or negative infinity, there isn't an exact y value that the function is approaching. So I will just write end behaviors. Not applicable. It's oscillating. Next, we can go on to our continuity. This function is continuous. Once again, there are no breaks or holes or asymptotes for this function. And next is symmetry. And for this example, we can actually look at this as both line symmetry and point symmetry. If we look at point symmetry, and let's say the origin here, if I were to take this right side of my function and rotate it 180 degrees, this piece here will match perfectly with this top left piece and will continue. So we can say that this has point symmetry. And because it's specifically at the origin, we can say it has odd symmetry as well. This does have line symmetry. If we take any vertical line where we have a minimum or a maximum, the right side can be reflected to make the left side. So for example, at x equals -2, if there was a line right here, this right side is a mirror image of the left side. But same thing here when x equals 2. Mirror image, x equals 6 or -6. So also line symmetry, and I'll say at x equals -2, although there are many reflection lines that we can use. Now we have our turning points, and there are lots of changes in direction here. So I have a turning point here at -10,4. Because I do know this function continues because of those arrows, that does become a turning point. If the function ended right there at -10,4, that would not be a turning point because there wouldn't be a change in direction, but this does continue, as I said. We have another turning point here at -6, -4, a turning point at -2, +4, 2, -4, 6, 4, and finally 10, -4. All of these are turning points because there is a change of direction for all of them. And these turning points are actually also our absolute max and mins. So our top ones are absolute maximums and our bottom ones are absolute minimums, all three of them. And there we go, all of our properties for various different functions.